Howdy and welcome back. So let's begin the setup of the type that we'll be constructing an iterator for. So the doubly linked list type that we're going to go ahead and create an iterator for will be the doubly linked list that you all have implemented within the DNA splicing activity. So you may recall this list of functions and behaviors. When we implemented our doubly linked list before we made it a class template, we provided this list. Thereafter, you went ahead in the DNA splicing MP, went and created a class template. So a doubly linked list for all types T. So we have a default constructor, parameterized constructor, another parameterized constructor, the copy constructor, because this list owns dynamic memory. So rule of three means we have to implement the copy constructor, the copy assignment operator, as well as the destructor. There's a couple of linked listy behaviors that we also had you all implement. This included the front operation, the back operation, pop front, pop back, push front, insert at, erase at, find, as well as clear. And then I guess there were a couple more. We had a behavior to check whether the list was empty, as well as another to return a size. And going through this, we were able to create doubly linked lists that were instantiated for different types T. In this case, the diagram shown below is a doubly linked list whose elements are storing objects of type character. So this is kind of what we have, and we're not actually going to modify things that we've already implemented for this type. I was just giving you a recap, and we'll see here that the iterators that we're going to implement are going to be their own type. So we'll see a doubly linked list iterator for all types T. But I wanted to go ahead and recap that, and then also probably necessary, let's just see the individual types of objects that are comprising this doubly linked list. It's going to be a node. It will store some sort of object of type T, which will be data. And then it will have, since it's a doubly linked list, not only a pointer to the next node within our sequence, but also a pointer to the previous node in the sequence. What we're going to implement today is the doubly linked list iterator for all types T. It will have a single private data member, current, which will store a pointer to some node of type T. We then have a default constructor, which would initialize current with the null pointer. We have a parameterized constructor, which would initialize current with the address stored in its parameter pointer. We're going to see here that we have the dereference operator, which we're going to provide an implementation for, both prefix and postfix increment operator, as well as both the measure operators to check equality as well as inequality. And with that, we'll go ahead and move on to the actual implementation of these behaviors.